For a question like this, a good diagram is of vital importance, so spend a minute or two looking at the diagram that I've got in the green box. Most of my diagrams look very similar to this when I'm solving a problem involving momentum and restitution. Just to go through it very quickly, so on the first line you see the initial conditions: a mass of 2m moving with a velocity of 2u, 3m moving with a velocity of u, and the third mass isn't moving. Obviously a collision will take place between the first two masses, and I've shown that. After that collision, I've said that the velocities of the first two masses will be a and b respectively, and in my second line of the diagram the final mass of mass m is still not moving, and I've put down there'll be a collision there. And then in the final diagram it shows the final velocities. Now a wasn't involved in that previous collision, so 2m wasn't involved in the previous collision, so it's still moving the velocity of a. The 3m mass will now have a velocity of c, and the last mass m will have a velocity of d. Of course, at this moment in time what we don't know is a could be negative. We know that b has to be positive just from the nature of the setup of the problem and the direction I've chosen as positive. We don't know whether c is positive or negative, and of course we know that d will be positive. That might not be important to the problem, but it's always a good idea to have a think through the problem thoroughly first. So the first thing to do is to show the speed of q immediately after the collision is 8.5 over u, and q is the particle with mass 3m, so the one in the middle. All of these questions essentially involve using momentum and restitution to get a pair of simultaneous equations. You then get rid of the variable you don't want, which in this case I think will be a, and you find out what the value of b is, and it'll be a vector amount. Sometimes you've got to think whether it's positive, negative, etc., but most of it's fairly obvious. So let's have a see how this plays out. So we look at the collision between p and q. First of all, just put in the information for the momentum. It will look like this: momentum before is equal to momentum after. A little bit of simplification leads me to a nice neat equation that 2a plus 3b is equal to 7u. Next we use the restitution equation, and we use minus e equals v2 minus v1 over u2 minus u1 as the preferred approach. Again, tidying this one up in a couple of steps leads me to another nice little equation like so. I'll call them 1 and 2, and I can see that if I add together 1 and 2, then a will cancel, and remember what I'm interested in is b, which is a vector amount, so we'll proceed on, and indeed it gives us the desired result that b is equal to 8u over 5. The next part says find the total kinetic energy lost in the collision. So what I need is I need to know what the velocity of a was. Let's have a see what happens. I'm just going to put my information down again. So this time I'm going to plug that value into one of the equations, and I will find out the value of a is 11u over 10. Okay, so what happens? The change in kinetic energy is the final kinetic energy minus the initial kinetic energy. So the final kinetic energy will be given by this expression. And make sure you're happy with y, that's the velocities of the two particles after the collision. And the initial kinetic energy will be given by this. Okay, I've left that for you to finish off. It's just a case of a bit of algebraic simplification, really, and you should see that it's obviously very easy indeed. Just a note of interest, for the delta K, I normally do final kinetic energy minus initial kinetic energy, which in this case I'd anticipate as being negative, and that will give me then the kinetic energy loss, which I'd then state as being a positive value. As I say, that's fairly trivial algebra. Okay, let's go on to have a look now at the last part of the question. I'm just going to do a diagram again, the same diagram as we started with, just for reference, and just recording the information that we found out so far. So what we're now going to do is we're going to consider this second collision. And again, we simply use the momentum equation, simplify that down as shown. We'll now use the restitution equation, simplify that down as shown. And again, we simply have a pair of simultaneous equations to solve. I'll call them 3 and 4, and I'll do 3 minus 4, which will allow me to find the velocity of c, and then I'm going to be able to determine whether or not there are further collisions. So let's have a see. That gives me that c is equal to 6u minus 2ue all over 5. And what I'm going to say is, for a further collision, we need that A has to be greater than C. Now, have a think about that, because we are talking about vector amounts here. And therefore, you need to have a think, well, if one of them is negative, what does that mean? If they're both positive, what does that mean? But with a little bit of thought, you should see that so long as A is greater than C, then of course another collision will occur. If they're both negative, have a think what that means. So for example, if A was minus u and C was minus 2u, then of course they would collide again, and that condition is met because minus u is greater than minus 2u. Of course, say if A was minus u and C was u, then A is not greater than C, but of course they're moving in opposite directions and no more collisions would occur. Anyway, let's plug in what we've got. That would mean that this inequality would have to be true, and all I've done here is essentially just worked it through. So 11u over 10 would have to be greater than 6u minus 2ue all over 5. Simplifying that down by simply multiplying each side by 10, and the 10 and the 5 cancel to give me a 2 on the right hand side, hence the 12u minus 4ue. I've then really divided throughout by u, which I can do here without worrying about the inequality sign because u is positive, and eventually that leads me to the condition that E is greater than 1/4. Okay, there's one final thing that I should do on this problem to make sure I get full marks, and that's to say that, well, E is greater than 1/4, however we also know that E should be bounded above by 1, so to finish this off properly, what I'm going to say is E is greater than 1/4, but it's less than or equal to 1, and that will earn us full marks.